Einstein's famous theory of relativity states that the only thing faster than the speed of light is the rate of expansion of the universe. According to this theory, it is impossible to explore the entire universe as it will always expand faster than we can travel. However, that may all be about to change as NASA has revealed the concept for its new helical engine, which breaks the laws of physics. Let's take a closer look. For centuries, ever since we realized that every star we can see in the night sky is a sun just like our own, with perhaps its own solar system, planets, and possibly even life, humanity has dreamed of crossing the astronomical distances separating us from the ultimate alien destinations. Even the nearest star is more than 4 light years away, while the fastest speed a human-created spacecraft has ever traveled at, reached by NASA's Juno mission, is a mere 46 miles per second. Even at that speed, it would take more than 4,000 years to reach the nearest star. There are 2 limiting factors: the current limits of our technology and the laws of physics. Advances in fields like laser sails, nuclear propulsion, or producing and controlling either antimatter or dark matter could provide a game-changing technological breakthrough, but appear to lie far off in the distant future. But physics-defying technologies, despite being often touted as the future, are fundamentally flawed. There are 4 fundamental forces in the universe: gravitation, electromagnetism, and strong and weak nuclear forces. The first of these forces is described by general relativity, the best theory of gravity we've ever concocted, and one that's passed every observational or experimental test we've ever performed. The latter 3 are described by the Standard Model, which describes all the known particles and their interactions exquisitely, passing every classical and quantum test we've ever devised. While future technologies might unlock the potential of the nuclear forces for space travel through fission, fusion, or even the annihilation of exotic particles with the normal, stable matter we find all around us, all of our conventional propulsion technologies rely on some type of chemical-based or electromagnetically based interaction or reaction. The vastness of space is one of the greatest mysteries out there. No one knows how big the universe is. The only perspective we have of its magnitude is capped due to our technological limitations. This has been one of the biggest hurdles in our quest for space exploration. Over the decades, organizations such as NASA have devoted significant resources to exploring our solar system. Even that has been a massive challenge due to the sheer size of our celestial neighborhood. Just a few years ago, the Voyager missions became the first man-made crafts to leave the solar system and travel to deep space, a feat that took multiple decades to accomplish. This is one of the many reasons why NASA has been hard at work to develop alternative methods of propulsion that would help us travel in space faster and more efficiently. Recent reports state that NASA has designed a near-light speed engine that breaks the laws of physics as we know them. This new engine is said to accelerate to 99% of the speed of light, all without the need for propellant. The idea has been developed by NASA engineer David Burns in his spare time, and on paper, it works by taking advantage of how mass may change at relativistic speeds. However, the report is yet to be reviewed by his peers. This study has understandably sparked interest comparable to that witnessed in the early days of the M drive. For a bit of context, it's important to know that the aforementioned M drive was NASA's first foray into the idea of actually trying to build an engine capable of faster-than-light travel. First introduced by Roger Scheuer, a British chartered electrical engineer with 48 years of experience in the space and defense industries, in 2001, M drive is a radio frequency resonant cavity thruster idea with possible uses as a spaceship thruster. It is claimed to create thrust by internally reflecting microwaves, in violation of the law of conservation of momentum and other physical principles. The media has frequently referred to the gadget as the impossible drive. Explanations for how the M drive could function go beyond the limits of known physics. Perhaps it's interacting with space quantum times vacuum energy, even though space quantum times vacuum energy doesn't enable anything to push off of it. Perhaps our notion of momentum has been shattered. Perhaps it's brand new physics, as announced by the M drive tests. There is no official design for this device, and neither of the persons who claim to have developed it has committed to explaining how it may function as a thruster or what elements constitute it, making it impossible to determine whether a particular object is an example of such a device. NASA's Advanced Propulsion Physics Laboratory reported observing a small apparent thrust from one such test in 2016, a result that has not since been replicated. Subsequent studies have indicated that the thrust observed was a measurement error caused by interactions with the Earth's magnetic field or thermal gradients. In March of 2021, scientists from the Technical University of Dresden published 3 papers explaining that it was a total fluke. The thrust was explained by outside forces. As for the helical engine, while it is intriguing, it is unlikely to defy the laws of physics anytime soon, despite the claims. Although it has been met with skepticism from some quarters, Burns believes his concept is worth pursuing. In its simplest terms, the engine works by taking advantage of how mass changes at the speed of light. One way to break down this concept is to envision a ring inside a box, attracted to each end by a spring. When the ring is sprung in one direction, the box recoils in the other, as is described by Newton's law of motion. Every action must have an equal and opposite reaction. When the ring reaches the end of the box, it will bounce backward, and the box's recoil direction will switch too. However, if the box and the ring are traveling at the speed of light, things work a little differently. At such speeds, according to Albert Einstein's theory of relativity, as the ring approaches the end of the box, it will increase in mass. This means it will hit harder when it reaches the end of the box, resulting in forward momentum. Generally speaking, the engine itself will achieve a similar feat using a particle accelerator and ion particles. This is because chemical, nuclear, and electric propulsion systems produce thrust by accelerating and expelling propellants. Deep space travel is often a trade-off between thrust and large propellant storage tanks that eventually limit performance, and this is what makes this idea so compelling. Dr. Burns states that the objective of this paper is to introduce and examine a unique engine that uses a closed-cycle propellant. The design is capable of producing a thrust up to 99% the speed of light without breaking Einstein's theory of relativity. However, the plan does breach Newton's law of motion, violating the laws of physics. That's not the only thing holding the helical engine back. Scientists believe the engine would have to be 650 feet long and 40 feet wide to work. Additionally, it would only operate effectively in the frictionless environment of deep space. NASA is not the only organization looking for ways to travel faster in space. Elon Musk is taking science fiction a step closer to reality. His company, SpaceX, says it has created a thruster system that defies physics and has successfully tested it. The rocket propulsion system uses electrically charged gas and can achieve speeds up to around 135,000 miles per hour. The engine is made from super lightweight carbon fiber fuel tanks with cold gas thrusters. It doesn't use any type of propellant, meaning it does not expel any byproducts into space. Instead, the engine produces thrust by accelerating superheated plasma with magnetic fields, which also means no fumes are being expelled from combustion. These types of engines are known as electric thrusters, but they work very differently from those used in SpaceX's Falcon 9 rockets. These thrusters create thrust by propelling pressurized gas, whereas electric ones produce a charged plasma that emits ions to push a craft forward. The electric engine developed by SpaceX is reportedly more powerful than conventional gridded ion thrusters and could power manned missions to Mars and beyond. It could also cut down on travel time for spacebound cargo because it requires less propellant, which can be expensive to launch into orbit. The technology is still being tested, and further development is needed before it will be ready for space flight. It has been submitted for peer review, and NASA experts think it has potential, at least on paper. Some say it's impossible to travel at high speeds through space, but that hasn't stopped Elon Musk from claiming he can do it. His idea is to create a light-speed engine that will take us to Mars in just 70 days. Such an engine defies physics and would mean traveling faster than 186,000 miles per second. There are a few ways that we could travel at light speed, but first, we need to understand how light works. As it travels through space, every atom in its path interacts with it. This slows it down and even stops it completely if there's no matter around to pass through. Because of these interactions, light has a maximum velocity of 186,000 miles per second, meaning that's as fast as it can go through space. Since nothing can travel faster than light without breaking the rules of physics, if we want to catch up with a distant star in our lifetime, we have to find another way to get there besides traveling directly towards it. The current way that we measure speed is the distance over time. To travel at light speed, or 186,000 miles per second, you would need to accelerate past that velocity until your speed was 186,000 MPs, then hold it there for an infinite amount of time. This velocity is referred to as c and was defined by Albert Einstein in his theory of special relativity. We haven't yet reached what most consider to be light speed, although many experiments and theories suggest that we may one day be able to approach it or even surpass it within our lifetimes. Until very recently, it has been generally accepted that nothing in our current state of technology could even begin to move at a velocity close to what we consider light speed. Some estimates place us thousands or even tens of thousands of years away from ever reaching it. That being said, we are often surprised by what science and technology can accomplish, and scientists have now managed to make an engine capable of reaching a mere 10% of light speed, defying these previously held assumptions about what is possible for our technological capabilities in today's day and age. The invention of an engine that could reach such high speeds would allow us to travel through space much more efficiently than before. If you like this video, you may also enjoy this one, which talks about the science behind the Merlin rocket engine as explained by Elon Musk. Do you think the helical engine will work, or will we have to wait longer to explore the universe? Please let us know in the comments section below.